Welcome to the introduction of Apache Storm. Apache Storm is a powerful, distributed, real-time stream processing framework. It's like Hadoop but for real-time data. This framework allows you to reliably process unbounded streams of data, doing for real-time what Hadoop does for batch processing. Let's explore the key features of Storm. It offers real-time processing, which enables it to process unlimited streams of data in real time with guaranteed message processing. Storm is also fault-tolerant, automatically restarting failed processes and redistributing tasks across cluster nodes. This ensures your data processing continues uninterrupted. Let's compare real-time processing with batch processing. This will help you understand where Apache Storm fits in. In terms of processing speed, real-time processing like that done by Storm occurs in milliseconds to seconds, whereas batch processing takes minutes to hours. When it comes to data volume, real-time processing handles continuous streams, while batch processing deals with large, fixed datasets. For use cases, real-time processing is suitable for fraud detection and monitoring. Batch processing is typically used for analytics and generating reports. In terms of complexity, real-time processing tends to be more complex, while batch processing has a simpler implementation. Now let's discuss the architecture of a Storm cluster. At the heart of a Storm cluster is the Nimbus node, which serves as the master node. It distributes the code and assigns tasks to the worker nodes. Worker nodes are managed by supervisors. Supervisors monitor the worker processes running on their machines. The actual execution of the Spouts and Bolts, which we'll cover shortly, happens within worker processes under the executor. To maintain coordination across the cluster, Storm relies on Zookeeper, a distributed coordination service. Zookeeper helps manage the cluster state and ensures smooth operation. Let's delve into Storm topologies. A topology is a directed acyclic graph, also known as a DAG, of computation that defines how data flows through your Storm application. Think of it as a network of connected processing nodes that transform streaming data. Within this topology, data flows from spouts to bolts. Spouts are the sources of data. Bolts are the processing units where the actual transformation and analysis take place. These bolts process the data and can then output it to storage or pass it on to other bolts for further processing. Let's take a closer look at spouts and bolts. Spouts are the data sources that emit streams of tuples into the topology. They read from external sources such as Kafka, databases, or APIs, and emit tuples to bolts. They also handle message acknowledgement. Bolts are processing units that transform, filter, or aggregate data. Bolts process incoming tuples, perform business logic, emit new tuples, and send them to the next stage in the topology. Bolts can perform operations like parsing, filtering, or joining data streams. Here's a simple example of how a Storm topology might look in Python, using the stream parse library. We have a word spout class that emits the tuple hello Storm continuously. Then we have a countBolt class which processes tuples it receives. It takes the first value in the tuple, which is the word, and emits the word along with a count of 1. The word spout emits string tuples continuously. The countBolt receives the tuples from the spout. The bolt processes each word and counts it, and finally the results flow to the next component. Stream groupings define how tuples are passed between spouts and bolts. Different groupings offer different ways to distribute the data. In shuffle, grouping tuples are randomly distributed to bolt tasks. This is good for load balancing. With fields grouping, tuples with the same field values go to the same bolt task. With all grouping, every tuple is sent to all bolt tasks, which is also known as broadcasting. Finally, in direct grouping, the producer, in this case a spout, decides which task receives each tuple. Choose your grouping strategy based on your specific data processing requirements. Finally, let's compare Storm with other popular stream processing systems like Spark Streaming and Kafka Streams. In terms of latency, Storm offers sub-second latency, similar to Kafka Streams, while Spark Streaming has latency in seconds. When it comes to the processing model, Storm uses true streaming, Spark Streaming uses microbatching, and Kafka Streams uses event streaming. Storm offers record-level fault tolerance, Spark Streaming uses RDD lineage, and Kafka Streams offers partition-based fault tolerance. In terms of complexity, Storm has moderate complexity, Spark Streaming is higher, and Kafka Streams is lower. Storm is best suited for real-time extract transform load, ETL, processes, Spark Streaming for analytics, and Kafka Streams for event processing. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.